Hello guys, it's me Elijah. In this video, I will be talking about the Safetran Type e-bell. Alright, so the Safetran Type 3 electronic bell, e-bell, is one of the most successful and widespread solid-state railroad crossing signals in North America. Originally introduced in the 2000s to replace unreliable older models, it features a rugged, all-metal housing and a distinct electronic ding that can change pitch depending on how its wires are configured. Now let's get into the history of the bell, shall we? Okay, Phase 1. Predecessors and Design Failures, 1990s. Before the Type 3 was born, Safetran systems struggled to transition from its popular mechanical bells to the emerging solid-state market. The mechanical era baseline. Safetran's mechanical bells were heavily produced from the early 1970s until 2005. They were incredibly popular but required high maintenance because of physical moving parts, clappers, and gongs. The Type 1 failure. In the 1990s, Safetran released the Type 1 electronic bell. It generated a highly unique, digital chime but suffered from a catastrophic design flaw. Its physical shell featured a plastic cap/housing. UV exposure from the sun made the plastic brittle, causing it to crack, let water inside, and fail prematurely. The Type 2 misstep. Safetran released the Type 2 to course correct, but it failed to capture broad railroad interest. Safetran eventually halted production and sold the design to National Electric Gate, NEG. NEG still mass produces this design today, meaning most Type 2 style bells in the wild are actually NEGs. Phase 2. The birth of the Type 3, 2000s. Determined to engineer a nearly indestructible model, Safetran launched the Type 3 electronic bell in the mid-2000s. The bulletproof shell, to completely eradicate the plastic structural issues of the Type 1, the Type 3 was designed with a heavy, powder-coated cast aluminum housing. It weighed 10.5 pounds and measured 20.5 inches tall. Technological innovation. It introduced a built-in diagnostic microphone sensor. This microphone physically listens to the bell's chime. If the speaker fails, the microphone reports the silence back to the Seir 2 event recorder in the signal bungalow, which automatically alerts the railroad dispatchers. Electrical parameters. The bell was built to thrive in extremes, operating flawlessly from -40 degrees Fahrenheit up to 158 degrees Fahrenheit and drawing a modest 6 watts of average power on a 12V DC system. Phase 3. Corporate mergers and rebranding. The physical appearance of the Type 3 bell serves as a historical record of the railroad signal supply industry's consolidation. The exact same underlying bell technology was stamped with 3 different brand names depending on the year of production. Number 1. Safetran Systems Era, mid-2000s to 2009. The original production runs feature the classic bold Safetran lettering across the metal front face. Number 2. Invensys Rail Era, 2009 to 2013. Safetran was fully absorbed into Invensys Rail Systems. Units produced during this window were cast with the Invensys logo. Number 3. Siemens Era, 2013. Present. Siemens officially acquired Invensys Rail for $2.2 billion in 2013. Siemens kept the Type 3 in active production but heavily redesigned the exterior housing around 2015, replacing the wide, flared mounting base with a significantly narrower, streamlined base. Phase 4. Tone customization and modern market status. The secret jumper wire. Safetran built the Type 3 with dual tone flexibility. By default, the bell plays a deep, rhythmic, traditional low-pitched ding. However, inside the circuitry is a small jumper wire loop. If a signaling technician cuts or disconnects this loop, the internal processor instantly alters the frequency, switching the bell to a rapid, piercing, high-pitched tone. Regional preferences. Major freight lines, BNSF, Union Pacific, CSX, deployed the low-pitch Safetran/Siemens Type 3 as their default signal. Conversely, regional transit networks like the Southeastern Pennsylvania Transportation Authority, SEPTA, heavily adopted the high-pitched wire configuration for commuter lines. The modern battle. While the Safetran/Siemens Type 3 remains an industry standard on regional mainline crossings, it faces intense market competition from the General Signals, GS, Type 3 e-bell, which entered the market in late 2015. Here are the documented specifications summary tables. Specification: Detail. Material. Heavy powder-coated aluminum. Weight. 10.50 pounds, 4.76 kilograms. Height. 20.5 inches, 52.07 centimeters. Voltage range. 9 to 16.5 VDC, 12 V nominal. Power draw. 6 watts, average. Operating temp. Minus 40 degrees Fahrenheit to plus 158 degrees Fahrenheit, minus 40 degrees Celsius to plus 70 degrees Celsius. Unique hardware. Internal diagnostic sensor microphone. This is the end of this video, so I hope you guys enjoy it. Like always, like, subscribe, and share my videos to anyone. Thanks for watching.